Welcome everybody to our May seminar. Today we have smart forestry and its education, new directions in modern forestry development. It's an honor for me to introduce Professor Dr. Huaguo Huang, College of Forestry, Beijing Forestry University. His research and work is quite impressive. He works on smart forestry, major technologies in smart forestry, practice of quantitative remote sensing in forestry, innovations and challenges in forestry education. Professor Wang Huaguo is also doctoral supervisor and distinguished professor with the Ministry of Education of China, director of the Smart Forestry Research Division at the National Key Laboratory, and a member of the China Committee of the International Society for Digital Earth. He's also an active member of editorial boards of very important journals like the Journal of Remote Sensing, Forest Ecosystems, Journal of Beijing Forestry University, and Journal of Remote Sensing. So welcome, Professor.
I'm so glad and honored to have this chance to introduce something about smart forestry. And smart forestry is a very frontier topic. It's a quite new topic. So maybe there's something not major, just a discussion. So I hope all the colleagues and the professors, students, you may have some ideas. We can talk about it later. Okay, so let's begin. The topic is about smart forestry and education. Since it's from the Asia Pacific Forestry Education Coordination Mechanism, so education is a very important part. A very brief introduction has been given by Christine. Thank you. And for me, I majored in forestry when I was an undergraduate student. And then I pursued my master degree, majored in GIS, then the PhD for the remote sensing. So that's my academic background. And here is the contents. First of all, I will give an overview of smart forestry and then some major technology. The third part is my main practice in remote sensing areas. Last two are some discussion. First of all, I must to mention human civilization has entered a new stage of information society. So information and intelligence are inevitable for us. Nobody can escape from this stage. So we must face it. In 2008, IBM has proposed a new concept of smart Earth. But actually, I found online it is called a smarter planet. It has three elements called IoT, that's Internet of Things, and interconnection intelligence. So that's the 3I or 3L. And in 2017, Microsoft has put a lot of money to develop the AI for Earth. So AI or smarter things has become popular in this year. But how about the smart forestry? I think it begins a little early, but it is still far behind the smart cities and the smart Earth. Here is some pictures I found from the IBM. IBM created a smarter planet. You can see it everywhere. And some icons Each icon show a smart area like smart energy, smart cities, or even smart food. So for Microsoft, it has a website called the AI for Earth. It created a planetary computer. This computer can provide a platform for a lot of computation. Here is an example about the deforestation risk analysis. If you are interested, you can find it online and try the website. It is very similar to the Google Earth Engine. And then for China, actually, our scientists have also developed some idea or concept. This is called iEarth. Earth is a brain of the whole system. And then it has the iEarth, the data, science, analysis, and the decision system. So the objective is for the sustainable development. So how about the smart forestry? Actually, the concept has evolved from digital forestry to precision forestry and smart forestry. In 1980s, one professor from our university, Beijing Forestry University, he proposed the concept of digital forestry. And then in 2013, our governor issued the guiding opinions on the development of smart forestry in China. Here, I found a literature. It is called the Digital Forestry, published in Journal of Forestry in 2005. In this paper, we can find that the digital forest, the concept was developed in 2004. This is a very a public international workshop. And it has developed some concept from different skills and different information skills. About the precision forestry, actually, I found a literature in 2010. The principle of precision forestry is it uses modern tools and technology to get as much real information as possible. So the objective is to improve decision-making process. This is for the precision. This is normally for the accuracy. And then I found some company, they have also using the concept of precision forestry. It means using wide range of technology like the drones or UAV, LiDAR, and a lot of sensors to monitoring the forest. So you can find from this website. And then another interesting website is the Internet of Trees. It also provides solution to use sensors to measure parameters in forest area. It's mainly to do not use much human intervention with some automation technology. Then for the education, smart forestry, actually in 2017, the University of Quebec, it developed a monitoring network. This network can help understand the mixed forest ecosystem. And in 2020, the Cambridge University, it developed a system using the remote sensing, IoT, AI, and cloud computing. And also the Norwegian Institute of Bioeconomics, it also driving forestry into industry for and increasing for growth by 20%. In China, in 2021, Nanjing Forestry University launched the first major of smart forestry. And then a lot of universities have developed this major. In 2022, Beijing Forestry University established a second level discipline of smart forestry. We still do not have the major for the undergrad students, but we have the discipline for graduate students. Actually, what is smart forestry? Indeed, we have no concept or definition accepted for all the people, but the official one from the government, it is has a definition, make full use of cloud computing, the IoT, mobile internet, big data, AI, and other information technology to build a new model. So we can use this concept. And then the Nanjing Forestry University, the Professor Cao Lin, he had published a paper. And we can see that phenotypic monitoring, the silviculture and forest fair wildlife are the four major content. And now I will turn to the major technology in smart forestry. As I has told you, no common concept for the smart forestry. So this map, this figure is only my opinion. For the smart forestry, it must has the smart infrastructure. We need to have WSN, that's wireless sensor network. And we will need the satellites, UAV, and even the airplane or the tower, this kinds of platform. This infrastructure is very important to load the sensors on. And then we can do the sensing and the computing. Sensing means we use the sensors like LiDAR or radar and some optical sensors. After collecting this kinds of data using sensing technology, we will using the computing technology. Here we maybe have a main computer or the edge computing. We were using some AI technology or the cloud computing. So this is the basic concept framework for the smart forestry. Actually, the major part of the technology will include, of course, computer and the internet. This is the basic things. And then we will have the GPS, remote sensing, UAV and GIS, and also some technology like big data, WSN, cloud computing, or mobile phone. So here are the major things, technology. And then typical applications for the smart forestry include the pest, the disease and pest, and also the fair, the wildfire, and also the carbon monitoring, biodiversity. This is normally we know. Besides this, we will using this technology to help breeding, smart breeding, or estimate the log volume or the tree volume. And some governments will use this technology to supervise some things. So after that, I will go into the major part of what I am doing. Actually, I studied the quantitative remote sensing. I use this in forestry, so I called it QRSF. The history of remote sensing of forest can begin from very early years, but it normally use some airborne RGB images or the photos to classify or zoning. And then it uses some statistic software to estimate the volume to tell a value. Then the third age is the quantitative inversion. It can give some precise or give some values of volume or leaf area index or something else. And lately, the smart sensing has become more important. We will use some AI fusing technology. So the objective of the QRSF is try to provide some high quality services. It is not only for the management, but also for scientific research or the education. This is the theoretical framework. Actually, I graduated from the Chinese Academy of Science. I majored in quantitative remote sensing. So that's the left part. And then I work in Beijing Forestry University. I will to know clearly the user demander, and then I will link them together to create this QRSF. I want to do some smart things for forest, especially in remote sensing. But actually, I know it's very difficult. Why? I compared with the meteorological industry or the land or the agriculture area. They have some better operation. They have the operational satellites, or they have very high resolution data. Or for the agriculture, it is very easy to observe. But for forestry, it's very difficult because the trees are so tall and heterogeneous. And in the mountain, many cloudy or rainy bad weather, so it's very difficult to observe or even to put the sensors on top of the canopy. And also not too much money. So this makes smart forestry very difficult. And then the accuracy is another problem. The remote sensing cannot provide very accurate results. And also the satellites is not available when you demand them. For the scientific difficulty, I can give you some examples. The underdetermined problem. For example, remote sensing can only take some pictures. So how can we use a few pictures to inverse the many unknown parameters? And then the mountain, the terrain effects, the scale effects, and also the saturation effects, and the multi-layer structure. Due to the time limit, I cannot explain them, but I will show you some Chinese poem to explain this. Here, if you know Chinese poem, it was quite beautiful. The sun is shining on the beach, but the piece of willow catkin are flying looking red. So we know the willow catkins are white, but it looks red. Why? Because of the sunshine, the setting shine, and also the pitch. Another poem is about the mountain, how you can see the mountain from the side or front. You will see different things. So this is the scale effect. Another effect is the angle effect. The grass appears green when you from a little bit far, but when we get closer, it will seems to be absent. So from demands to the scientific, we will know the problems and how to solve the problems. So I call this MAFI. That means we will know the more accurate and fast and intelligent. The theoretical modeling is quite important. So we have to develop the 3D model or the one-dimensional models. They have their own advantages. This is the technical development. We will have the observation platform from the space to the airborne platform or even to the ground, the tower. And then we will have the 3D models to simulate a lot of things. Finally, we will using the AI driving models to serve real-time remote sensing to do some operational mapping. So this is our objective. Here is my quantitative modeling. This is 3D model, and then this is the 1D models for the pest management. Here is for the real-time simulation. This model has been developed from 2004. Actually, in 2007, I developed the thermal band, then to the large scale version and to microwave band. Now I have developed this to the real-time version. I create very beautiful trees, realistic trees from deciduous conifer bamboo, and we do some simplification and use some unified scenes and unified models to simulate the satellite images. This is for the large scale simulation. This is for the branches. The objective is try to improve the accuracy. Here we have a software. In this GUI, we can create a 3D thing of one tree or a forest stand and simulate the spectrum or the images. This is for the microwave radar signals because radar is quite different from our RGB images. And here is the radar signals varying with time. Here is an interesting result. The x-axis is the age. That, in other words, the biomass. And the y means the remote sensing signals, radar signals. So the radar signals will change with the age. It will be good for us. We can inverse biomass. So for the C band, it does not very much, but for the P band, very long band, it will change a lot. So P band is our requirement. And then, but the QU band is also interesting. We use this to simulate the waveform. This is not LiDAR, this is the radar waveform. So this waveform tells us the vertical profiles of trees or forests. And we can use this software to simulate both optical and the radar scattering signals. This is for leaf. In the same GUI, you can simulate the leaf optical and the microwave or even thermal things. Here is some examples. For soil, we can also simulate the soil reflectance or the backscattering, the branches, and it can also select full waveform things. This is the 1D model. The 1D model means it will be run faster. So, and it maybe will easier to inverse. This is an example. We have some beetles. These beetles will attack the forest and make the leaf become red or yellow. So we'll use this model to develop this kinds of affection and simulate the reflectance. This reflectance will help us to inverse to the damage degree. And for the fluorescent, we also simulate the healthy leaves or the dead leaves. They will have different signatures. Even for the leaf, we will go details about the leaf structure. We'll go to the cell scales. The upper phase and the lower phase will have different reflectance. And then the real-time retracing model will simulate the LiDAR sensors from here. We have animation. We will simulate the UAV aboard the LiDAR. It will scan the forest. This kind of scanning will get the top of canopy information, but the bottom information, how to achieve this, we will try to simulate the sensors and the forest. So that means we will change the mode of the scanning, go faster. Yeah, we'll simulate this kinds of sensors on the ground. It will scanning the forest. It will scan the DBH easier than the UAV. This kinds of information can combine together to measure the trees more accurate. Okay, and then we will link these kinds of information together. We open it in the software. This point cloud will help us to develop some algorithms. And then we'll have some practice and applications. Here, for the ground survey and for the inversion, quantitative inversion, and fair pest disease are our major content. This is for the leaf area index. We have some instrument. It may be much expensive. So we're thinking how maybe we can use our mobile phone, smartphones, equipped with lens. This is the hemisphere lens. We will catch the photos underground and use these photos to inverse the leaf area index. That means everybody will measure this data. And then we use some cheaper LiDAR sensors. This is the VLP16 lines LiDAR. We use this to scan the trunks. So each trunk will give some different signals. So we develop some algorithm to easily estimate the DBH and the basal areas. And this is for the leaf area index. We use this VLP LiDAR and to inverse the priority and the leaf area index. This is in the burned area. This is fair burned area. Also, we use some thermal cameras. These cameras to try to catch the leaf temperature or the branch temperature. This temperature will help us to validate the satellite temperatures. And then we also use some RGB images taken by the UAV. We segment these kinds of UAV images to get the corresponding point cloud. If we have this kind of cloud, we can classify them. So classify individual trees using deep learning method. And then to large areas, we use satellite images to inverse the coverage fraction or the forest tree height biomass. And then we also do some rocky desertification. We use the UAV images to collect the fractions of these rocks and try to invert them from the Landsat images. Then we try to use the mechanism models to simulate a lot of 3D scenes and the 2D images. Then we inverse the tree fractions from the 2D images. This is use some AI technology. And then we use the 3D models to simulate the Yunnan pine, the forest scenes. The red means it has been attacked by the beetles. So these kinds of disturbed forest stands, we can use the UAV, can use the 3D models to invert them. In optical regions, we can direct inverse the dieback rate. And for the radar images, we can also use the backscattering coefficient and also the interference coefficient to inverse the different degree of healthy. Thermal images are also used. This is the cover story of a journal. You can see the red one may have a higher temperature. And we use the UV to take the thermal images. This is the plot areas. So higher temperature will have a high, maybe it will have the suspected affected pest. And for the single tree dieback rate, we use the UAV collected LiDAR point cloud and the 3D models. Also, we simulated the future sensors. It does not exist now, but in the future, it maybe have some hyperstructure LiDAR sensors. So we simulate if it can inverse the tree damage by the disease. For the forest fire, we linked the optical images and the thermal and the microwave. The interesting thing is that here is the optical images. We see the smoking here, but in the radar images, we can penetrate the smoke and see the burned areas. Another thing is the line change detection. Use some deep learning method, and we're also supporting the anti-poverty, try to detect the change by a human. Finally, we do some biomass estimation. This is for the Huaguo River. We use some remote sensing and GIS to analyze the distribution of biomass. Okay, for the education, actually, I like teaching, so I use some technology to help to support teaching. This is in 2020. I used the Blender software to create a lot of animation, a lot of videos. This video will tell the students how the remote sensing works. I'll give some examples. This one is tell the students how the terrain will change the shadows, will change the satellite images. So it will have a good visualization. Students will make it easier to understand. And this one is to help students understand how retracing works. So this is a photon. One photon will go into the vegetation, the canopy, and will be scattering in it and go out or absorbed by the leaves. This one is for the laser scanning. Oh, it doesn't work. This one for the for the airborne LiDAR sensors. Okay. The for part for the education, actually, more university in China has offered the major of smart forestry. I found online many universities you can see from the south to the north, from the west to the east. The Nanjing Forestry University has become the first one to launch the major, as I told you, and some agriculture for university, Henan and Jilin Agriculture University, they have also developed this major. So what courses they have, they are teaching? I show you the list. This is from the Northwest Agriculture and Forestry University. Actually, they will have the pest disease fair and also some monitoring, remote sensing. Remote sensing must be the key course. And the Internet of Things, the GIS, the AI, and the equipment. So how about the Jilin Agriculture University? You can see they have the precision, cultivation and management, and intelligent design about breeding. They will focus on breeding. Also the disaster. For the computer science and technology, they will also learn these kinds of courses. They will learn Python to do some programming and IoT and big data monitoring. For the Fujian University, Agricultural University, they will have some basic courses. Bonneting, soil, okay. But for the core courses, the GIS, remote sensing, big data, they also passed. Okay, so this is very special. Forestry carbon sink and project design. So how to teach better? Actually, we can use some online education resources or some practical training. And the internet education, just like us, what we are doing. In the field, we may use some LiDAR sensors. Here is an example in Australia. They use the LiDAR sensors to scan in the forest and tell the students how to measure the trees. And this is for our Beijing Forestry University. Our young teachers from other universities, they don't know too much about forestry. So we will lead them go into the forestry, go to the field from the south to the north. Also, the UAV will be the practical operation. Actually, the education is a little bit far from industry. So I found some companies, they have also developed the smart forestry system. They have already invented using some technology in forest fire, disease, or the biodiversity, a lot of things. So I know the gaps. This is from the China Tower. China Tower has a lot of resources of the tower. Many sensors will be on board the tower to take pictures or take some thermal images of the fair, the wild animals, or the cutting. This is from the Ellipse Space. This is a company. They have developed the smart forestry, will give the real-time monitoring. But actually, they will mainly use the satellite. They will launch a lot of satellites. Okay, since the time is limited, I will give a very quick review for this. Here, the conclusion and outlook. The inevitable and the key directions, I think, should be for the smart forestry. This will be available for the modern forest development. And then we will make full use of this technology and use some innovation to improve the quality of management. But the limitation, my focus is on limitation. The education of smart forestry is just the beginning. It's very young. And then I found the gaps between education, research, and industry. For example, the major is very young. It is only for 3 or 4 years. But how about the jobs? How about the market for the students to find? We don't know. And whether the industry will accept these kinds of students is also a question. And then the AI role is more important. So the AI is changing our research education. For example, the research, we will have the AI for science. This is very hot recently. This is an example from the University of Canada. And then for education, education is also, the AI is shaping the future of learning. We have entered education, the level 4. So how AI can help education? Actually, it can support the teachers, and it also help the students as well. It can support, can give the personalized learning. So we must adapt to this new stage. Okay, that's all. Thank you for listening and the question. Thank you.
Thank you, Professor. A new era is coming, and it's very interesting how you're trying to promote that our students connect the new technologies with the old challenges, right? We have some questions. Professor Damrong Pitpatwa would like to make a question. You can say it, or you can write it down in the notes section. Welcome, Professor Damrong.
Yes, thank you very much. And thank you, very good presentation. So I consider that the modern forestry and the conventional forestry should be integrated together. And then my question to speaker, what do you think about, do we need to combine it or not? And if so, how to combine a modern technology into the conventional forestry? The reason of my question is because of the AI people or IT people is very specialized people who may not based on forestry foundation. That is my question. Thank you.
Okay, thank you. That's very good question. Actually, I think combining a conventional and the modern is a must. Conventional technology, or for example, we measure the trees by hand. It will give us the very accurate results. A modern technology like a LiDAR will improve the efficiency, but it will not replace the measurement on the ground. So this is the combination. Ground measurement, the conventional technology will give the validation, will give the basic data to train the modern technology. And the modern technology will improve the efficiency or extend the limited points to large areas. So this is one aspect of the combination. Another aspect is the modern technology will not exist by alone. It will not. It must to get some demands, requirement from the conventional technologies. That means somebody will develop the AI, will use some deep learning algorithm, but it don't know how to use or where to use. So it must go to the field. It must to ask somebody, the scientist with the conventional technology, so that they can help each other. So that's my answer. I hope it works.
All right, we have two more questions. Are there any ways or methods to use ground surveys to validate or correct or increase the accuracy of the results from smart forestry? For example, insect outbreaks? From
Okay.
Christina again.
Yes, for the insect outbreaks, this is a good example because I have done a lot of work on the insects, some beetles, but I also know it's very difficult because we didn't know the damage is caused by insects or disease or fire or windbreak or other things. We don't know the reason. Remote sensing can only see the results, can see what happened, but it didn't know the reason. So the ground survey will help to know what happens, to help know the reasons. So this is quite similar with the first question. But how to validate or increase the accuracy? I think we can use some IoT technologies, that Internet of Things. For example, we can install some equipment on the trunk. In this trunk, we'll steam some needles into the trunk. It will measure the sap flow or collect the information of the water or the nutrition transport within the trunk. By this information, we may detect the beetles or the wood-boring beetles attacking. This is very difficult for us. But for the leaf-eating insects, it will be easier. The leaf will fall. We can collect the leaf on ground, use some equipment. So I think the modern technologies will help the ground service. So this is my, it's maybe not maybe not sufficient for you, but we can discuss it later. It could be. Thank you.
Okay, another question from PM says, how expensive dollars per hectare is to develop a basic smart forestry monitoring system? And I would like to add to that question, what kind of sensors or equipment you consider the very basic for a smart forestry monitoring program? What is the cost per hectare, and what are the key sensors that you would use to say this is a smart forestry monitoring program?
Well, this is quite a practical question. In fact, I found some companies, they have developed some smart monitoring system. For example, I just give some examples. They have developed equipment. This equipment will collect the insects and trap the insects, automatically identify which insects are. This is a quite automatic equipment. It will cost about 10,000 yuan in China. Okay, 10,000 yuan, maybe 1,000 euro per yuan. Okay, this is just for 1 point. And then we still need the UAV You can buy a UV and a LiDAR sensor. This will cost around the 10,000 yuan. And for the remote sensing, for satellite images, you will not buy some equipment. You just buy the images. So it maybe depend on your use, on your areas. So a basic, I don't know what it means, a basic smart forest. It will, according to your demands. If you will monitoring the insect, okay, it's a topic. If you will monitoring the growth to capture the volume, this is another topic. So I think the basic smart forestry will depending on your requirement. But at least I think it's not very cheap. It will be expensive. In the future, it will become more and more practical for us. I think it is still a little bit far from the practical operational application.
Okay. Another question from Anka Awal Sembada. Thank you for your insightful presentation. Is it important in a small forestry to consider the interaction of canopies and pollution deposition on the canopy, since some forests are prone to pollution from nearby industrial activities?
Okay, that's a very new idea for us. For the pollution, I think we have considered this because we have studied the relationship between the dust on the leaves. We use the remote sensing technology to inverse the dust information and relate the dust to the PM 2.5. So I think it is a quite a similar topic about the pollution deposition. But actually, for further studies, we did not do that. But for our 3D models, our models can simulate them. If it can have a very clear mechanism, how this pollution affect the spectrum. If we have this, we can use the reflectance to inverse the pollution. That's my answer.
Okay. Well, I don't see any more questions in the chat section. So people are really happy and impressed of your excellent work and insights in the new developments of artificial intelligence, Internet of Things, and communication that opens new opportunities for the forestry sector and for the environmental monitoring of so many variables that we need to understand to take the right decisions. I assume that artificial intelligence is going to play a major role on forest management as well, and droughts and other catastrophes that are looming on many forests around the world. Well, thank you, Professor Huaguo Huang, for your talk. Thank you, everybody who connected in Zoom and YouTube. And this presentation will be available in our website, the APFnet website. So you can tell your students and colleagues to look into this website for previous talks and the coming talks next month. So this is everything that we would like to say for tonight or this morning for you in Asia. And thank you very much for coming to this excellent talk.
Thank you, thank you. And if you have any questions, please send the email to me. We may discuss about it deeper, okay? Thank you, thank you. Thank you, Christine. Thank you all.
Bye-bye.